Section 6.3, page 334, try it yourself 1. In a survey of 1,006 adults from the U.S., 181 said that Abraham Lincoln was the greatest president. Find a point estimate for the population proportion of adults who say Abraham Lincoln was the greatest president. So all they're asking you for here is your p hat, which is the x divided by n. And so our x in this case is the number that believe that Abraham Lincoln is the greatest president, which is 181. And the n is the total sample size of the survey, which is 1,006. So this is just a sample. We're giving an estimate. So you're going to do 181 divided by 1,006. So your calculator is just 181 divided by 1,006. And that'll give you 0.1799 and so on. Let's go 2 decimal places to 0.18. Or our point estimate is going to be 0.18. Now let's take a look at Try It Yourself 2 on page 336. Use the data in Try It Yourself 1 to construct a 90% confidence interval for the proportion of adults that say Abraham Lincoln was the greatest president. So let's start by finding our formula that we need to use, which is going to be p hat minus z sub c times the square root of p hat times q hat divided by n is less than the population proportion p is less than p hat plus z sub c times the square root of p hat q hat over n. And so we already have the p hat here, which is 0.18, and from that we can find our q hat, which is just 1 minus p hat, which is 1 minus 0.18, and that'll give us a q hat of 0.82. We also have the n here, right up here, which is 1,006. So the only thing we don't have is a z sub c. So our z sub c is going to be for a 90% confidence interval, and so to find that we need to look in our table 5. So we've just got a 90% confidence interval. So our 90% confidence interval all the way down, because we have a very large sample, is 1.645 for our z sub c. That's going to be 1.645. I'm going to stick all those numbers in here. Our p hat is 0.18 minus a z sub c of 1.645 times the square root of the 0.18 times your 0.82 divided by the n of 1,006 is less than p is less than the p hat of 0.18 plus the z sub c of 1.645 times the square root of your p hat 0.18 times the q hat, which is 0.82 divided by the n of 1,006. And so let's go put those in our calculator. So we're just going to have the p hat, which is 0.18, minus our z sub c, which was 1.645 times the square root, which is second, x squared, the p hat, which is 0.18, times the q hat, which is 0.82, divided by the sample size of 1,006, and that'll give us 0.160. So we'll just round that off to 0.16 is less than, p is less than, and then we're just going to go back here and change this minus to a plus by hitting second enter, going back to our minus and changing it to a plus. So we got 0.1999. We're just going to round that off to 0.20. So we are 90% confident that the portion of the population that believes Abraham Lincoln was the greatest president is between 16 and 20%. Section 6.3, page 338, try it yourself 3. You wish to estimate with 90% confidence and within 2% of the true population the proportion of males aged 20 to 34 who have high blood pressure. Find the minimum sample size needed if, for part 1, no preliminary estimate is available. So here's an important thing about no preliminary estimate is available. that you want to have the highest possible p hat q hat. And so the formula to find the point estimate, the sample size that you need, is n equals p hat q hat times z sub c over e, which is our error, and then that would be squared. And so if there's no preliminary estimate available, you want to use the largest possible combination of p hat q hat. And so whenever there's no preliminary estimate available, always use p hat is equal to 0.5 and q hat is equal to 0.5. That'll give you the largest possible product, because if you do p hat q hat 0.5, 0.5, that'll give you 0.25. And so in this case, we're going to do n is equal to 0.5 times 0.5. Now our z sub c we need to find, this is a 90% confidence interval. So we need to find a z sub c for 90%. And so we're going to go to our table 5 again. 90% confidence interval will give us 1.645. So that's going to be 1.645 for our z sub c. And now the error they give us up here is 2%. So if the e is 2%, that's going to be 0.02. And then we're going to square that. So let's put that in our calculator. So it's just going to be 0.5 times 0.5 times 1.645 divided by our error of 0.02, and then we're going to square that. And so we'll end up with 1,691.26 whatever. We always round up, no matter what, whether that's a 2 or a 1 or a 0, that 1 is going to go up to a 2. We don't round correctly when it's sample size. So our n is going to be about 1,692, because you're talking about the sample size. How many do you need to question? Well, you need to get more than enough is what you need. Now let's take a look at part 2. A previous survey found that 6.4% of males in this age group had the high blood pressure. So that's our actual p hat. And so that's 6.4%, which is just 6.4 divided by 100. So our p hat is going to be 0.064. So that leaves our q hat to be 1 minus that. So that's going to be 0.936. So now we're going to put that in place of the 0.5, 0.5. So here our n is equal to 0.064 times 0.936. And then the rest of it is going to be the same, times 1.645 divided by 0.02 squared. So let's put that in our calculator. 0.064 times 936 thousandths, or 0.936, times 1.645 divided by 0.02, and all of that's squared. And that's going to give us 405.254. We always have to round up. We're going to put that in as 406. And so if we have this previous survey that found 6.4% of males in this age range that had a high blood pressure, then we're going to need to survey at least 406 of them.